We're continuing our journey through the history of the atomic theory, going into Bohr's model. You can see this is covered on page 146 to 152. I'm going to teach you what Bohr's model is, and then we're going to work with it more tomorrow in class. So, taking a look at where we are and where we're headed. We have talked about Democritus. He thought that atoms were these small spheres. They went to Dalton, who was kind of the same idea, but then he came up with these 5 big ideas. Then you had J.J. Thomson, who thought it was a plum pudding, kind of like a cookie model. We moved on to Rutherford, who understood that there's a nucleus, and that's where we're at right now, that we know there's a nucleus and the electrons rotate around it. So this is kind of what we think the atom looks like. A nucleus in the center, and electrons are around. But there's a problem with Rutherford's idea. Well, if electrons are negative and they're on the outside, and the center is a positive nucleus where the protons are, and electrons, negative things going around positive things, isn't it at one point that the electrons and protons are going to attract each other so much that the whole atom implodes? That's a huge problem, and that's what they thought back then, and they realized that this was a problem. But they knew that Rutherford was on to something, so we had to make it better, and that's why Bohr came about. Here's Bohr, Niels Bohr. Handsome-looking fellow from 1913, not too much, kind of around the same area as Rutherford in time frame, and he pictured the atom to look like this. It's still that planetary idea where you have the nucleus in the center and the electrons travel around, but these rings that they live on are called orbits, and the orbits are the energy levels. And he said something new is that each electron has a fixed, which is the orbit, energy level called an orbit, and it cannot fall into the nucleus. The electron has to live on these rings. Kind of like our planets have to live in those orbits. The electrons have to live in the rings. They can't possibly fall into the nucleus. Something to notice for this part, they're called energy levels. Notice there's an N here. And each ring has an N, so this is N1, energy level 1, N2, energy level 2, and that's why they chose N. Something else to note is when you're drawing your picture of the atom, if you're copying this picture, be very careful in your distance of the rings. Notice from the first ring to the second ring, it's a small distance. Much smaller than this ring, which is third to the fourth, or 1, 2, yep, third to the fourth, it's bigger, and then even bigger yet. So make sure when you draw your circles, it's a small ring, and that rings get bigger and bigger, in which the distances get larger and larger. Okay. So that's what Bohr thought, and it reminds you of a ladder. If you are going to climb a ladder, you can't step in between the 2 rungs. You'll fall straight down to the bottom rung. Just like that, electrons can't step or live in between the 2 rings. They have to live on the rings, called the orbits. So you think of it as a ladder for electrons. Now the question is, how did Bohr come up with this? What was his experiment? A little background here. You know, if you take a light and you shine it through a prism, you're going to see the whole rainbow. That you've seen before, and that's how we get rainbows, is the raindrops are actually the prisms. So in the same idea, what he did is not taking light, like light from the sun, is he took a helium lamp, so he has just helium inside there, added electricity, and it creates a light. That light he sent through a prism, and he noticed that he didn't have a full rainbow, he has just certain lines. If you look at this image, he's got a red, a yellow, maybe a green, blue, and 2 other blues. Not the whole rainbow as he was expecting. This has got to be indicative of what the helium atom looks like. And that's his experiment. His experiment is called the atomic emission spectrum. That's when you can pass light that's coming from some sort of element source through a prism, and you can see only certain bands of color. This is his experiment. And he found that when he did different elements, notice here's a list of different elements, each of them showed a different spectra. It's kind of like elements' fingerprints. Every element has a different spectra. Kind of like every person has a different fingerprints, and that makes us unique. Every element has a different spectra, and that makes them unique. So we can use this to see what kind of element we have. Now the question is, what does this tell us about what's inside the atom? How do we know what that means? So let's go back to this image of what the atom looks like and figure out, how did we get these colors? Let me get myself a pen. Let's say you're an electron. You're living right here. You're completely happy. You're running around the circle, living your life. This is called ground state. Ground state is where you're happy, in your home base. And if you think about the spectra, then we plugged it in and add electricity. Now you're excited. You got electricity. You're really excited, so you're going to jump out of your home base, and you're going to live in the next ring. That's called the excited state. Now when you're in an excited state, kind of when you think about when you go out somewhere, let's say you go on vacation. You go out on vacation, it's really exciting out there. You're living in a different place, sleeping in a hotel and things, but eventually you do want to come back to your home. Eventually the excitement or the energy is worn off, and so you need to come back home. This is the same for an electron. Electron is living in his excited state. He's not happy there all the time, so what he's going to do is fall back down to his home base. And at his home base is where he will stay, his ground state. Here's where the colors come in. So you're living in your happy place. N3, that's your ground state. You absorb energy, that's step 1. Absorb energy and move out to an excited state. Step 2 is you're not happy in the excited state, you can't stay there. Step 2 is you fall back down to a lower energy level towards the nucleus. And when you fall back down, step 3 is you're going to emit colored light. Colored light is the energy that's being released from it. Wow, that looks terrible. Colored light is what I'm going for. And so that's how we can see different colored light. Now you could be an electron and you could live in this spot, and you could jump way out because you might absorb a lot of electricity or any kind of energy. Step 1, absorb a lot of energy, move outward. Not happy here in this excited state. Step 2 is you're going to move downward towards your home base or ground state. That's step 2. You might have to do this in 2 leaps, which means you're going to form 2 different colored light. So there's your 3 steps. Step 1, absorb energy, move out. Step 2, release the energy, move down. Releasing the energy is your colored light. And we can see that depending on where the electron is excited and how far he jumps in or out tells us what colors we have. And different energy levels have different colors, and that's how we can see what we see. I'll show you this computer animation. So here's an electron, he's a blue dot, he's traveling around. Energy source comes in, he absorbs, and then he releases the energy as he comes back down. I'm going to click on a high energy level. Here's that happy electron just floating around, gets energy and absorbs it, moves way out, and falls back in. Notice that there are different colors of lines that they're showing, because that's the different kinds of jumps that they're making. Different jumps show different colors. Okay. So Bohr observed only certain colors were given off. So if you were hydrogen or helium, or this top one is mercury, if you're mercury, you have certain colors because your electrons can only live in certain places. And since every atom has different colors, that means every atom can have different jumps, which means every atom's rings must look a little different. You could have a little ring and a little ring and a little ring, and that might be one atom. Or next atom might have a little ring, a little bit bigger and bigger. See, the different sized rings and distances between the rings creates the different kinds of jumps, which creates the different colored lines. So he knew that every atom had to look different, that they all had rings, but every atom had different kinds of rings because I could see different kinds of jumps in the spectrum. And that's how he came to his model of the atom, the Bohr's model. It's just called that, the Bohr's model. I got a Google form here. It'll be a link on the YouTube. Please go and do that, and I'll see you tomorrow. Bring your questions.